Okay, let's wrap this up. So what I've done is I plugged in my numbers to figure out the energy level of n equals 1 and n equals 2, and those answers are in electron volts. And then I know that 1 electron volt is the same thing as 1.602 18 times 10 to the negative 19 joules. So I made that conversion to joules. Okay? The reason why I made that conversion to joules is because this equation only works for joules. Because if I have energy which is in joules, and that's going to equal Planck's constant here, which is joules seconds, and I'm going to multiply that by frequency, which is inverse seconds, so we have joules is equal to joules, right? Or that if we divide by our Planck's constant here, and we divide by that, then we're left with 1 over seconds, which is frequency. Okay, so I did that change in frequency because if an electron is jumping from a higher energy level to a lower one, that change in energy is going to equal the energy of the photon that it emits. So the higher minus the lower, and then this is that change in energy. Be mindful and careful because here's my higher minus my lower, and so our negative signs are important. Negative 5.4, etc., minus the negative 2.17. Okay, so that was the energy, that change in energy right there. This is also the energy of the photon. If I want to figure out the frequency so that I can then get to the wavelength, I will divide by that constant. And when I do that, when I take this energy divided by that constant, it gives me a frequency of 2.466 times 10 to the 15th hertz. And that makes sense because light is around the range of times 10 to the 14th, right? So we're in that range. That's wonderful. It didn't ask for frequency, though. It asked for wavelength. And these are electromagnetic waves, right? Photons, maybe in the ultraviolet or the infrared range. And so we know that the speed of the wave, which is the speed of light, will equal to the frequency multiplied by the wavelength. So if I do speed of light divided by the frequency, that will give me my wavelength, where the speed of light is 2.99 times by 10 to, times by 10 to the 8th, not a negative there, meters per second. Okay, so that's what I'm going to do. I'm going to take that 2.99 times by 10 raised to the 8th, divided by that frequency that I just calculated, and I get 1.21, we'll do 3 sig figs, times 10 to the negative 7 wavelength meters. Okay, wonderful. So on the activity, you're going to be talking about the electrons jumping in energy levels and what kind of wave would you expect, something with high frequency and low frequency. Okay, best of luck with the activity.